Hey everyone, how are you all? I think who are we missing? I think we're still missing Jordan, but he's been having some connectivity issues the last day or two. So we'll see if he can show up here. And I see Laura, you are here. I don't know if you all know Laura Farmer from the Dungy Writing Studio. You've probably come along with Laura or some of her minions at different points in time during your Cornell career. So I think Laura was basically just going to say hi and maybe talk a little bit about the services that the Dungy Writing Studio can offer you as you guys work toward doing your literature review paper. So Laura, I'm just going to let you jump in here and say a few words.
That sounds great. Good morning, everybody. Hope you're all doing well. It's nice to see everybody. So I've been chatting with Todd a little bit about your assignment, the different ways that this assignment is paced, and the different pieces that will be part of this. So the peer review, different revisions, etc. And so I just wanted to pop in and remind you that the Writing Studio is open. We are available. We are more than happy to meet with you at whatever stage you are in with this paper. All of our appointments are online right now, and the easiest way to make an appointment is if you just go to the Writing Studio website through the library. And once you go to the Writing Studio website and you click on the link that says schedule an online appointment, you will be taken to our online scheduling system, which is so slick and easy. The greatest thing about this platform is it was designed specifically for writing centers, so it's really easy for us to use for this purpose. You just register for an account, you log in, and once you log in, you will be taken to our schedule, and from here you can see what we have available for today. If a slot has been filled in, if there's a color on it, that means that slot is occupied. If it has not been filled in, that means you are welcome to schedule in that slot. You can schedule for a half hour or for an hour conference. And then in order to begin the session, you just simply log back into this system, you click on your box, and you are whisked away to an automatic online platform where you'll be able to talk with your consultant one-on-one, you can share documents, you can write on a whiteboard, you can have a true collaborative experience. So we're trying to make our online system as close to our in-person system as we possibly can. So do you guys have any questions? Anything that you're thinking about at this early stage? All right. Well, just let us know if we can help. We'll be happy to see you.
Great. Thank you so much, Laura.
Thanks, Todd.
All right. Bye-bye. Yeah, I mean, in my opinion, I think probably the Writing Studio is probably one of the more underutilized tools that most students have in their toolbox here. I mean, I've seen students that have made dramatic improvements in their paper, and it's hard to convey your ideas if you can't write them, right? And so I've seen a lot of papers over the years ruined by simply kind of shoddy writing that could have been helped by just getting another set of eyes and somebody that's experienced in how to write. So anyway, I'm not going to require that everybody set up an appointment to go to the Dungy Studio. I don't think I feel the need to do that. But I'm going to strongly recommend that all of you at some point in time in this process set up an appointment and spend at least a half an hour with a writing consultant, right? And so obviously the consultant's not going to be able to help you with content, right? That's what I'm here for, or that's what, that's how we can help each other when we do our peer reviews, right? We can help with the content, but they can certainly help with, making your paper more readable and flow better, and just tell you, even if you don't know the content, sometimes you can sit down and look at a paper and like, oh, this is a well-written paper, or, I can't follow this. I can't follow, what's the thesis here? How are you supporting your thesis? So anyway, strongly encourage all of you at some point to think about to set up at least a half an hour visit with one of the writing consultants, and they can help a lot. So, okay, well, we made it to Friday. Congratulations. Yeah, right. I don't know about you. It seems kind of like a long week. The first week should be quick, right? It didn't seem so quick, but I don't know. That's just me. Time is incredibly elastic now that you spend, 98% of your time in your house or in your dorm room, as the case might be. So today, what are we going to do? We really have two things that we want to, or I'm sorry, really three things that we want to talk about here today before I let you get on your way for the weekend. First, I want to talk a little bit about Chapter 9 and what are called endogenous growth models. And this is really going to be kind of a setup for what we talk about on Monday when we talk about the Romer model. Okay, so we're gonna talk a little bit about endogenous growth models here. That won't take too long. After that, we're going to talk about the Lucas paper that you were asked to read, Lucas 2000. We're going to kind of go through that and kind of approach it as an opportunity to think about how do you read economic articles, right? How do you read economic literature? And then we will have class this afternoon. I hope to keep it fairly short, but my plan this afternoon is to go and do a little bit of an econometrics review, right? Now, this is something that some of you might feel very strong with your regression analysis skills. Some of you might not, but I thought it would be worth spending a little bit of time reviewing that and trying to make sure that we understand some basic concepts. In part because as you begin to look for papers, you're going to see a lot of papers have an empirical component. A lot of the papers are going to use regression analysis. And so I think there's some basic things that we should all be familiar with as we read through these papers. So we don't have to be econometricians. We don't have to be have a deep knowledge of econometrics, but I think there are some basics that we need to be familiar with, or you're really going to get bogged down in these papers. And so, with the idea that hopefully some of you begin doing some research for papers for your literature review this weekend, I wanted to talk a little bit about that this afternoon, and just kind of hopefully put a few things in your mind that you can use as you begin to look through possible articles. Okay. So jumping into the first topic here we're going to talk about, let's talk about endogenous growth models. Okay. What do we mean by endogenous growth models? Well, the Solow model that we've been talking about is really an exogenous growth model. And as you look through papers, you will actually see people use this language. They will talk about exogenous growth models. And when they're talking about exogenous growth models, they're really talking about models like the Solow model, right? So in the Solow model, growth comes from A in the long run. And it's exogenous, right? The Solow model does not explain where A comes from. And so it's in that sense that the Solow model is an exogenous growth model. So what's an endogenous growth model? Well, in an endogenous growth model, things like the savings rate or the population growth or education, remember education is U, impact growth in short run and the long run. As a result, growth is explained endogenously within the model. So as opposed to growth being completely exogenous, in endogenous growth models, they're trying to explain where growth comes from, looking at things such as the savings rate or population growth or education. There are a wide variety of endogenous growth models out there. A wide variety of endogenous growth models out there. But in this class, we really want to talk about, well, this morning we're going to talk about 3 simple examples. And then on Monday, we're going to talk about a 4th example that we're going to spend a lot more time talking about, which is the Romer model. But to kind of help us get ready to think about the Romer model, I wanted to talk about a couple of examples of growth models that economists have sometimes used. So let's kind of work through these examples one by one, just to get a feel for other types of models of growth, right? Alternatives to the Solow model. So one example, and this is a very simple model, is something called the AK model. Okay, the AK model is just based on a very simple idea. What if there were no diminishing margin returns and alpha equaled 1? What if there was no such thing as diminishing margin returns and alpha equaled 1? So let's think about a version of our Solow model, but without diminishing margin returns. Okay. Notice here, there's no diminishing margin returns in this model. We don't even have labor, right? So if there's a 10% increase in K, there's a 10% increase in output. No diminishing margin returns in this production function. So what does the Solow diagram look like? Well, think about it. Sorry. Stupid. I don't know, somebody has gotten my number. Keep on calling me with these freaking trying to sell me ridiculous stuff. All right, sorry. So let's graph this Solow diagram. So here's delta K. What is S bar times Y? It's just a straight line. We have 2 straight lines here. Without diminishing margin returns, the production function doesn't curve over, it's just a straight line. Where's the steady state?
Nowhere.
Nowhere, exactly, nowhere. In other words, we have sustained growth. Right, we have sustained growth. The K dot is greater than 0 forever. And also notice that growth increases as S bar goes up. So unlike in the Solow model, where growth was a function of A, but savings could not impact the rate of growth in the long run, here, savings can impact the rate of growth in the long run. So this permanently increases growth, right? It's a permanent, as opposed to the Solow model where it's a temporary. So there is no steady state. In this model. Anything that increases savings rate leads to an increase in growth. Now, okay, that's interesting. What's the problem with this model? Do we really believe that there's no diminishing margin of returns? I mean, does this model pass the smell test, right? Do we really believe that there's no diminishing margin returns? Well, that seems hard to argue, but some economists have tried, right? And so the second model that I want to talk about is a model by Robert Lucas, who we're going to read here, his 2000 paper in a minute. He has another paper dating back to 1988 in which he builds a model of human capital that has endogenous growth. And here's Lucas's idea. He says, well, maybe we can think of alpha equal to 1, meaning no diminishing returns, if we think about capital as both human and physical capital. In his model, an increase in things like education then increase long-run growth rates. So what Lucas says is if you think about capital as both human capital and physical capital, you can get a model in which you have output growth that is permanently affected by things like spending more money on education. So let's think about what this model looks like. So just like yesterday, he has a production function that has human capital in it. Right? Where little h is per capita human capital. And yesterday we assumed that this was the case. Yeah? But Lucas says no. Let's think about it like this. Let's assume that what is the change in human capital over time? The change in human capital over time is really created by two factors. How much education you have, but also how much human capital you have. Okay? Here is a key idea. And this is really one of the reasons I want to talk about this, is that this is going to be an idea that we come back to on Monday when we talk about Romer. Notice what's happening. What you have in this assumption is that the more human capital you have, the more human capital you accumulate. So having more human capital means that human capital grows faster. This is like what you would call it, a virtuous circle. Or we can also think about it as what's called increasing returns to scale. Meaning what happens as you get bigger, you actually become more productive. So the more human capital you have, the more human capital you get here. And, you know, I think there is something intuitively appealing about this idea, right? The more human capital you have, the more likely that you have people that are going to be learning on their own, figuring things out, using experience. And also, there's the possibility of networks of knowledge, right? The more human capital you have, the more you have what we can think of as thick networks, right? Thick networks means lots of different kinds of interactions between people in which they can improve upon the human capital that they have. So that's Lucas's idea. He really takes the model we talked about yesterday and he says, wait a second. Instead of just assuming education only increases the level of output, it could actually increase the growth rate of output, because the more human capital you have, the more human capital you accumulate. So as a result, if we rewrite this formula, we see that this can be rewritten as H dot H is equal to U. In other words, the growth rate is equal to U. And in this model, it's also true. Oh, I should put this in per capita forms. Sorry. That output grows at the rate of U. So if you spend more on education in this model, you grow faster. Unlike the model we talked about yesterday, where if you spend more on education, it just increases the level of output, here it actually increases the growth rate of output as well. So you can see what fun economists can have, right? This is why there's so many models out there, because really you can take the model we talked about yesterday, right, here, and just change one equation, right, one assumption about how human capital increases production. Yesterday we made one assumption, today we make another assumption. You get much, much different results, right? You get much, much different results. And so in this model, if you spend more on education, you will permanently grow faster. You will permanently grow faster. Let me talk about one last endogenous growth model, right? One other endogenous growth model. This one is also going to be somewhat related to the Romer model that we talk on Monday. And this is a model by Helpman and Arrow. Dates back to 1962. And this is what's called the learning by doing model. Right, the learning by doing model. So in this model, here's the idea. Learning by doing is a good description of it. How do firms and individuals increase their productivity? By producing. The more you produce, the more you increase your productivity. Okay? It's an increasing returns to scale argument again. The more you produce, the more you increase your productivity. Okay? So think about an individual firm. they have this production function. So for an individual firm, they have this B, right? B is something akin to total factor productivity, right? We talked about this a couple days ago, total factor productivity. And it's exogenous. An individual firm takes aggregate productivity as exogenous. Now, here's the insight of this model. What happens at the aggregate level? The more you produce, the more it increases total factor productivity, and it increases B. So think about it this way. An increase in aggregate output creates, a positive externality. For individual firms. So total factor productivity is exogenous to individual firms. They're too small to really impact total factor productivity. But what happens at the aggregate level? At the aggregate level, total factor productivity is equal to how much you produce. You can increase B by having more capital or increasing technology. And here A is more narrowly defined as technology. So if you plug this into the production function, you can get an aggregate production function. And what's the aggregate production function? Let me actually do this. Well, B, remember, is this. And then if we go up to our rest of our production function, we have this, right? This is B that we've plugged in. Or simplifying this, we get this. Whoa, what happened? Where's the alpha? Is there diminishing marginal returns in this model? No. There is at the individual level, but at the aggregate level, there's not. Because the more that's produced in aggregate, the more capital you have in aggregate, the more that it increases productivity that offsets those diminishing marginal returns. There's no diminishing marginal returns here in the aggregate. There's no diminishing marginal returns. This is just like the AK model that we talked about a few minutes ago. It's just like the AK model. So a change in S, or if you added education, or if you added population, all those things will permanently increase growth. Okay. So if you think about these endogenous growth models that I've talked about here, what kind of properties do they all tend to have? Well, I think there's a couple of things that these models that I've talked about, either the learning by doing or the human capital model or other models, and there are a wide range of endogenous growth models, right? There's a very wide range of endogenous growth models, but they do all tend to share the same properties, I would say. They all tend to have increasing returns to scale or positive externalities. In other words, what one individual does also impacts other individuals, right? So if you think about that learning by doing model, where does growth come from? It's the fact that if I produce more, I help you produce more. And if you produce more, you help me produce more. Likewise, that human capital model is very similar. If I get more human capital, you get more human capital. And if you get more human capital, I get more human capital, right? So these models all tend to focus on increasing returns and positive externalities that lead to growth. As a result, here's one of the interesting implications. Being rich makes you richer, and vice versa. Being poor makes you poor. In other words, you have the possibility in these models of poverty traps or virtuous circles. A poverty trap is, I think we talked about this a little bit yesterday. When you are surrounded by people who don't have much of an education, what's your incentive to get much of an education? Not high, right? So when you're trapped in poverty, the incentives are, there's very few incentives to help you get out of poverty, right? And vice versa, when you live in an area that's rich in human capital intensive, that makes it easier for you to get more human capital, right? So there's the possibility here of poverty traps or virtuous circles. In the learning by doing model, if you live in a rich country, when other people produce, that increases your productivity and makes it more profitable for you to produce. But what happens if you live in a poor country? Then other people not producing makes it less productive for you to produce, and so you produce less as well, right? So we have these feedback loops, right? I guess that's another way of saying this. Feedback loops. The final thing that most of these endogenous growth models share is they do not predict convergence. In fact, if they predict anything, they predict divergence for the reasons we just talked about. When you're rich, it's easier to become richer. And when you're poor, it's very difficult for you to break out of those feedback loops. And so the rich get richer, the poor get poor, and you're going to have divergence. That's what you tend to get in most, if not every endogenous growth model, right? So just by changing a few assumptions here, you can get much, much different results than you get in the solo model, right? Once again, the solo model emphasizes two things: diminishing marginal returns and exogenous growth, meaning growth coming from factors that we're not really explaining. But there are a whole raft of other models that try to endogenize growth, right? In other words, they try to explain where growth comes from within the model. And almost all of these models rely on some form of increasing returns to scale or positive externalities. I really should have said this up here. Sorry to just kind of squeeze this in. But I really should have made this point. We talked about the solo model as a model of perfect competition, right? But what tends to be true in endogenous growth models? Imperfect competition. So when you have positive externalities and increasing returns to scale and feedback loops and spillovers, these are all examples of imperfect competition. Right? These are all examples of imperfect competition. And so there's market failure. Right? These are places where markets don't necessarily work perfectly because of these additional externalities that are created through production. So we can get models that come up with different conclusions from the solo model, right? Different conclusions from the solo model. Now, having said that, your author takes the position, and I honestly pretty much agree with your author on this. I guess that's one of the reasons why I use his book. That when all is said and done, though, these endogenous growth models aren't hugely persuasive, right? And so let's just talk about this a little bit. I'm not saying that they're not worth thinking about and that they don't give us some insights. But your author, and as I said, I can tend to fall into his camp, don't necessarily find these more persuasive than solo. Why? Well, I think it's largely an empirical issue, right? Which of these models tends to fit the data better? In your author's opinion, and I tend to agree, it's the solo model that tends to fit the data a little bit better, okay? Let's talk about this. One of the things that these endogenous growth models predict is that a change in savings rate or a change in education does it permanently change growth? do we find that when there's a change in the savings rate or the change in education, that there's a permanent change in growth rates? The empiric, excuse me, the empirics simply say no. That when you look at the correlation between savings rates and growth rates or educational rates and growth rates, just as we talked about yesterday, there's really no strong empirical evidence that changes in these things permanently impact growth. Look at the US. We have seen wide fluctuations in savings rates and education rates over time, wide fluctuations. But what's been true about economic growth? As we've seen, it's been relatively steady, about 2% a year. Yes, we do have ups and downs, right? But over the long haul, our growth rate has been pretty close to 2% a year. So we just have not seen these kind of empirical correlations between, for instance, big boom in education that took place in the US in the early 1900s, right? So in the US, the educational boom really took place in the early 1900s when there were big increases in primary and secondary school enrollment. What happened to the long run growth rate? It doesn't look like it changed, right? We had huge changes in savings in the early 1900s, and then dramatic falls in savings in the 1970s and 80s. Recently, we've had big increases in savings. Has this big increase in savings that we've seen over the last 10 years led to faster growth? No, right? So just thinking about the US as an example, and we could look at other countries as an example too. There's just much more stability in economic growth than there is in savings rates or education rates. It's really hard to think about these things as permanently impacting growth, quite honestly. Likewise, does economic policy that impacts the savings rate or education rate permanently change growth? For example, tax rates. Is it possible that a cut in taxes could increase savings, which increase growth? Do we see in the data things like tax rates significantly increasing growth? Empirically, no. Okay, this is just one thing that politicians, I got to get up on my soapbox here a little bit. This is one thing that politicians refuse to understand. Some politicians refuse to understand. If you look throughout US history, many studies have shown that there is no correlation between economic growth rates and tax rates. There is no correlation between economic growth rates and tax rates. This idea that somehow you stir economic growth by cutting taxes just does not exist in the data. Now, I'm not saying that cutting taxes or raising taxes doesn't impact people's welfare. It might impact their welfare. It might impact their consumption. It might impact a number of things. I am not saying that taxes don't matter. But what I am saying is, how does it impact economic growth? And the answer is, it's just not in the data. Once again, what's the US economic growth rate? About 2%. And that has been true when the US had a top marginal tax rate of 90%. It's also basically been true when the US has had a top marginal tax rate of what it is today, I think 38%. So there's been a lot of variation in tax rates in the US, not nearly as much variation in growth rates. And so, once again, not saying that government policy doesn't matter, but does it determine long-run growth rates? There's just not a lot of data. There's not a lot of empirical evidence for this. And so for those of you who are interested in tax policy or government policy and how it impacts growth rates, there's a wealth of empirical studies here, right? A wealth of empirical studies that you can look. This would be a good topic for your paper. And, I think in general, what you're going to find is that economists have really struggled, right, to find this. There's actually a recent paper that received a lot of headlines that came out last month that was looking at using a new and more detailed set of tax records, looking at whether the Reagan tax cuts of the 1980s led to faster economic growth. So basically testing the trickle-down theory of growth, right? The trickle-down theory of growth is you cut tax rates on the rich, and then they use that to invest and spur production, and then that helps out everybody down at the bottom of the distribution. What that study said is, no, you cut taxes on the rich, and what happened to economic growth? It didn't change, right? There's no demonstrable change in economic growth, and so there was no trickle down. And that's just another study that falls along this wide range of economic growth is just much steadier, right? It is there appear to be more fundamental determinants of growth than tax rates. So that kind of raises questions about these endogenous growth models too, because in a model like that learning by doing model, a tax on capital could significantly reduce growth. But we just don't see examples of that, right? I mean, the predictions of the model don't seem to really match what we observe. On the contrary, the predictions of the Solow model, which predicts much more stable growth, does seem to be a better fit. And then a final question we can ask ourselves is, does alpha equal 1 make sense? Are there diminishing marginal returns? And so in my opinion, there are, right? And I think this is really the opinion of a lot of people who find the Solow approach much more persuasive, is that yes, there's too much evidence of diminishing marginal returns out there for us to try to explain it away, regardless of how you define capital. Diminishing marginal returns is an idea that has been at the forefront of economics for over 250 years. And so I would just have to say, in my opinion, when ideas last for 250 years, there's probably a strong element of truth to them, right? Because economics, while it is not a science like chemistry or physics, right? We don't have the ability to run direct experiments. But, economic ideas do get tested by the scientific method. And so for ideas to hold up for that long, right, it really, I strongly believe it means there's an element of truth to it, right? And so, as appealing as some of these models might be, and I agree, some of these models intuitively are very appealing, right? They're very appealing. I actually, talking about the Lucas model where having human capital leads to more human capital, that's an appealing idea. And I think, and it's an idea that seems at some level to make some sense. But when it comes to the predictions of the model, you know, you ultimately have to evaluate a model based on, does its predictions fit the real world? And, you know, I think where your author comes down and where I come down is that these models are interesting and they encourage us to think about growth more carefully, but they don't really add much more to the Solow model. And so that's why the Solow model continues to be kind of the primary emphasis of this class. And I would say in growth literature in general, the Solow model continues to be pretty much where people begin when they think about growth. Now, there is one caveat to that. And that caveat is that, you know, it still is frustrating that Solow says that A bar is the most important. But it has nothing to say about where does it come from. And so there is one endogenous growth model that I do find more interesting and more appealing because it specifically focuses on the role of technology. And this is where we're going to go on Monday. The Romer model, which is an endogenous growth model which focuses on the production of ideas and technology. So the Romer model, while it is an endogenous growth model, is more in the spirit of the Solow model, in that it's really taking diminishing marginal returns as given, but it's saying we can say more about where A comes from. We can say more about where A comes from. And so one of the things we're going to see in the Romer model is it actually incorporates some of the ideas from these endogenous growth models that we've talked about, but finds a way to reconcile them with the Solow model. And so that's really going to be the topic of conversation for Monday. And for those of you who had me in intermediate macro, which a good chunk of you have, you're familiar with the Romer model, right? Or at least somewhat familiar with the Romer model, right? We talked about a simple version of the Romer model in intermediate macro. And so that's what we're going to come back to on Monday, right? On Monday, we're going to talk about the Romer model and talk about how it can actually help us think about where A comes from, right? It can help us think about where A comes from. Okay, so that's kind of all I wanted to say about Chapter 9 in endogenous growth models, right? And that's kind of a precursor in many ways to what we're going to talk about on Monday. So why don't we take a break until, let's say, just a little bit after 10 o'clock, all right? And then I want to come back and talk about that Lucas 2000 paper, all right? So see you in about 7 minutes or so. Hey, everybody. Okay, so let's talk about this this Lucas paper that I assigned you to take a look at. Did you guys, by the way, did you all enjoy 21, 21, 21, 21, 21, 21 yesterday? Do you know what I'm talking about? Yeah, I know it was inspiring for me. And by that, I mean, I actually missed it. I was looking for it and then I kind of got distracted. I look at my watch like, oh, I missed all those 21s. But anyway, Somehow life will go on. so, um, so here's an article. This comes from the year 2000, right? So it's about 20 years ago. And so this is actually kind of an interesting exercise for us. This model actually makes some predictions about what the future is going to look like. We've had 20 years now to kind of evaluate how accurate this model was in predicting what the future looks like. And so we can now talk about that, right? We can now talk about that, right? And so that's kind of the interesting thing about going back and looking at some older articles, is it actually gives us an opportunity to try to, evaluate and think about what did these economists, these big name economists like Robert Lucas, who's winner of Nobel Prize in economics, what are some of the things that they get right? What are some of the things that they get wrong? Now, we are going to talk about the results, but I also want to make sure that we are really clear that about, one of the things I want to take away from this is, how do you read an article like this, right? And not just reading, but also summarizing. Because that's going to be part of what you're going to have to do in your literature review. Is you're going to want to be able to take away what's important from this article, but not get too bogged down in the details, which is always a danger, right? Because the more we get bogged down in the details, because we are not PhD economists, or you're not a PhD economist, the more likely we are to get hung up on something that we really can't understand and can't explain. And so how exactly are we supposed to read a paper like this and be able to get the key insights and communicate them? Well, I think whenever you're summary of a paper, you're writing a summary of a paper or an article, you really want to be thinking about 4 steps or 4 things that you really need to focus on. And so your entire discussion should really be on one of 4 things. The first is, what is the question that the paper is trying to argue, to ask? And why is this question important? Right? So you want to figure out, what is the question that the paper is trying to ask, and why is this question important? That sounds obvious, but sometimes, having read articles, that this is the first thing you got to make sure, is that you understand what the question is, and you can put it into some sort of context for the reader. And for us, context means really class material, right? How does this add to our big 3 questions in this class about why rich countries are rich, poor countries are poor? Why do we have growth miracles and growth disasters? Right? So you really want to think, and you can kind of think about this as an introduction, but the first thing you need to establish is just, what's the question and why is this question interesting, right? Why is this question interesting? Second, you want to discuss the model, the process, and the data. Here is where you have to be the most choosy, though. Sorry, something's screwed here. Okay. It's in talking about the model and the process and the data that you're most likely to get a lot of technical stuff, right? You're likely to get lots of equations, lots of math, lots of econometrics results, right? You are not asked to understand everything in these articles, right? You really are not asked to understand everything. And I don't expect you to understand everything. But I am going to expect you to try to understand key ideas and to be able to express them clearly. So, what this means is you want to put this, for instance, how does this model differ from models we talked about in class? Is there a key intuitive difference? And when you're talking about the data they're using, you might want to focus not so much on all the data, where it comes from, or, once again, you don't want to get too much in the weeds here. But you do want to focus on what makes the data interesting. Is there something like a novel data set? Is there something, if it's an empirical paper, what is novel about the data, right? What's unique here? Then you want to talk about the key results and any intuition that helps us understand those key results. Once again, the goal here is not to discuss all results, right? You do not, once again, want to get into the weeds of discussing every single result in every single paper. For example, one of the things that you probably don't want to spend much time on is if you have an empirical paper, inevitably they're going to be doing what are called robustness tests. And robustness tests essentially say, if I change the model this way, do I still get similar results? A big part of any empirical paper in economics is a lot of robustness testing, right? So they'll have a model, they'll estimate the model, and then they want to say, well, this is a good model because look, what if I do this? I still get the same result. What if I do that? I still get the same result. What if I substitute this for that? I still get the same result, right? That is a lot of what empirical research is. That's exactly the kind of thing that you don't have to go into great detail, right? I mean, I think it's useful to mention that the author tests for robustness and how they might do that, but once again, you do not want to go into every single detail of all these robustness tests, because once again, I think that's too much in the weeds. So the key is, what are the key results here, right? What are the key results, and can you provide a kind of intuitive explanation of these key results? And then finally, you want to think about applications. What did we learn from this paper? How has this fit into our previous class discussions or material? Are there policy implications? Like, does this paper say something about what is a policy that could improve growth in a country? And as always, it's useful to, once again, come back and tie it into the big three questions of this class. Okay. So, I mean, that is a brief outline, and obviously different papers are going to require more time on one of these parts and less time in other parts. And, you know, I mean, there's such a wide variety of papers that you could be covering in this class that, you know, it's hard to give you a kind of a rubric for what you want to talk about in every paper, right? But I think in general, these are the kind of questions that you want to focus on. So with that in mind, let's think about this Lucas paper, right? What's the big question? Anyone can help me out here? What's the question that Lucas wants to talk about? And just repeating back to me the title doesn't count. Come on, what's the question? We're going to sit here silently until somebody at least gives me a half-assed question.
It's looking at like why different economies are like where they are throughout time.
Yes, right. Particularly in regards to what Lucas calls the diffusion of growth and the distribution of income levels, right? So how do countries differ across times in terms of the diffusion of growth? By diffusion of growth, we mean like who's growing and who's not growing. And in terms of income levels, right? In other words, do we see convergence across income levels? Do we see divergence? Lucas wants to kind of predict these. And so this is a model, just to be clear, that is looking forward. It's really trying to predict what's going to happen, not just in the past, but in the future. Okay, this is largely a theoretical paper. There's not really any empirics in this paper, right? Next week we will look at a couple of articles that have empirics in them, including one by Acemoglu and Robinson and Johnson. So we'll work through a paper like that next week that is more empirical. This one's more theoretical. And so given it's more theoretical, when it comes to discussing our second point here, we really don't have to think so much about the process and the data, but we do have to think about the model, right? And so who can help me understand what are some interesting things, or what are some of the key points about the model that Lucas uses? Gao-Ming, how can you tell me something that's interesting about the model that Lucas uses here?
Countries are kind of chosen at random when they're gonna industrialize and stop being stagnant. So it's not really like yeah, it's at random.
Yes, right? Yeah. So to back up here just a second, how Lucas kind of sets this up is he sets this up like a race. Okay? He sets this up like a race. Everybody is the same in 1800. And then, as Max said, countries start growing at different times. And he calls that probability lambda, right? So lambda is the probability that a country starts to grow. Okay? So everybody's at the starting line. The gun goes off. Some countries start running. And then every single country could or could not start running depending upon what their lambda is, right? And then just random chance, right? So there's a bit of randomness in this model, right? That there's not a perfect prediction when a country will start to run. It's kind of probabilistic when a country starts to run. What happens when a country starts to run? Do they run fast or do they run slow? Chase.
They run at a speed proportional to the difference between it and the leader. So faster if it's farther behind.
Exactly. The farther behind you are, the faster you run at the beginning, right? In other words, this is really diminishing marginal returns. This is really capturing diminishing marginal returns. That how fast the country grows, Lucas says, is based on this. The growth of country X is equal to alpha plus beta times the difference between the leader, the output of the leader, and output of country X. So Lucas says, let's assume that this is 0.02, meaning on average, when a country grows, it grows at 2%. But then it's also going to grow above that if it's below the leader. If it's below the leader, the more it's below the leader, the faster it will grow. This is catch-up or convergence. Or you can think about this as capturing a lot of the things that Solow talked about. Lucas assumes that beta is equal to 0.025. Or that convergence happens at a rate of about 2.5% a year. Where does he get this number from? This number comes from the empirical literature, okay? So there's actually a fair number of studies that have looked at when convergence occurs, how fast is it occurring? And most of the studies find a number that's really surprisingly close to 2.5% across the number of studies. So, you know, this is basically where Solow gets this number, as he appeals to the other literature, right? So, countries start growing. If they're far behind, they grow really fast, right? The farther that behind they are, the faster that they grow. So, in other words, the faster they converge. That's diminishing marginal returns, right? That's diminishing marginal returns. So this is very consistent with a lot of the things we talk about in the Solow model. Okay, then there's one last part of this model, and this has to do with lambda. Okay. That lambda, the probability that your country starts to grow, increases by delta as global income rises. So what Lucas is assuming here is that as the world gets richer, your country is more likely to grow. Does that make sense? Yeah, I think so. I think so. The idea here is as the world gets richer, as there's better legal systems and systems for international trade, and there's more openness, that even poor countries can begin to grow, right? Now, listen, I don't know that I completely buy this assumption, but it's an interesting one, right? It's not one that I think we can reject at its face value. So that's the model. It's a very, very simple model, right? It's a very, very simple model. It really only has kind of two equations. This equation, right? And then a second equation, Lucas doesn't actually write it, but a second equation that says that the probability that you start to grow rises at the rate of delta as the world gets richer. Okay, that's the model, right? That's the model. Okay, now let's talk about the key results. When talking about key results, I would say that most authors try to give you some help in identifying key results, right? In the sense that for the vast majority of papers, when authors are getting to key results, they're going to present some sort of figure or table or some sort of illustration to help you visualize what's going on. And so when you talk about absolute key results, I really encourage you to look through the papers and see, well, is the author trying to illustrate this key result through a figure or through a table or through something else that really makes it a little bit clear as to what's going on? And so, yeah, that's what Lucas does. So if we look in his paper, sorry, let me pull this paper up. Okay, so if we look in his paper here, we get to first this, figure 2, And what's figure 2 saying to us? Once again, this is looking at the fraction of the economies that are growing year by year. So what's happening to the number of countries that are growing year by year? The fraction of the countries. Well, initially it's very low, right? Because global income is very low. So there's very few countries growing initially. But as we get into the 1940s, 1950s, 1960s, we begin to see an increase, a fairly dramatic increase in the fraction of the countries that are growing. And then what happens when we get closer to the 2000s? The number of countries begins to level off. But that makes sense because we're getting close to 1 now, right? We're getting close to 1. Now we have well over 90% of the countries in the world that are growing. And so, what that means is as we get closer to 1, it's going to be hard, basically the rate at which countries enter the growing group is diminishing because there's so few countries left, right? There's so few countries left. Figure 3 is really the most important figure here that summarizes the absolute main takeaways of this paper. The top graph is the annual growth rate of the world, right? World growth rate. And the bottom figure here is the standard deviation of income. So the standard deviation of income, as hopefully we all know, is a measure of volatility or variability, or basically inequality, how unequal income is across the countries. So what does Romer's model predict for us? Initially, what happens to world income growth? It goes up very fast, right? Why? First, because more countries enter. And second, because when you first enter, you grow really fast because of diminishing marginal returns. So growth in the 1900s should be very fast, according to this model. But what happens as we get into the 2000s? World growth begins to slow down. Why? Because of diminishing marginal returns. There's enough countries growing now in the world, and they've grown for long enough that the growth rate is slowing down closer to that 2% long run growth rate. And so you notice out here in the very long run, in the year 2000, or sorry, the year 2100, growth goes almost down to 2% for the world, right? In the year 2100, almost every country is growing, and almost every country is going to be growing at their long run rate. And then finally, what's happening to the variability of income across countries? At first, it goes way up. Why? Because we have some countries that are growing really fast, and then we have a lot of countries that are not growing at all. But what happens over time? That income inequality across countries begins to fall. And so this Lucas model predicts that there's convergence going on. There should be convergence, and that world income inequality should diminish over time. Is this what we've observed? Now that we've gotten to the year 2020, we can ask ourselves, well, this is what Lucas predicted in 2000, right? Basically based on the Solow model. But what have we observed over the last 20 years? Have we observed this kind of convergence or this kind of increase in inequality across countries? So let's take a look at this here. So this data is not from Lucas. This is just my own data, right? But let's ask ourselves now with 20 years hindsight, is this what we've observed? And we've actually seen some of these graphs that I've shown to you. And we'll see that actually the Lucas model does a pretty good job of predicting in many ways what we've observed. First off, as we've talked about, if you look at the ratio of the poorest 10% of countries to the richest 10% of countries, the poorest 10% have caught up to the richest 10%. There has been a decline in inequality when you talk about the richest 10% relative to the poorest 10%. We saw this graph before. The world evolution of income has shifted to the right, right? There's more people that are living at a higher proportion of US income than there have in the past. But this is the graph I really wanted to show you. This is looking just like what Lucas, just like the article or the graph that Lucas showed. This is looking at the global income distribution in 1800, 1975, and 2015. So look at the global income distribution in 1800. It's way skewed toward the poor, right? Most people are living at very poor, low levels of income. And there's a really long tail out here to the right, meaning there's just a few people who are really rich. What did the world look like in 1975? Well, this was a poor world and a rich world, right? We have a poor world, a lot of people living at low levels of income. And then there's also kind of this second hump of people that are living at high levels of income. But what's happened since 1975? In general, this looks more and more like a normal distribution, right? It's not a normal distribution yet. It's still skewed to the left. But we can see it's becoming more normal, meaning more evenly distributed, where more people are living in the middle class and fewer people are living in extreme poverty. So I don't want to say that this graph is the same one that Lucas showed or Lucas generated, right? So if we take this figure, take a mind picture of that, right? And then we go back to this, if we go back to this, I don't want to say that this curve looks exactly like the one that we saw from 2015, but you can see, you know, the main prediction that Lucas made here is basically been shown true, right? Has basically been shown true, that the world does appear to be converging, not perfectly, not exactly. There are still some countries that are being left out, and this paper has nothing to say about how do we explain those countries in sub-Saharan Africa who still are not growing, right? I mean, I guess Lucas would say they still got time, right? But, you know, there does appear to be countries that just seem very resistant to growing. But taking that out of the equation, Lucas actually predicted the last 20 years fairly well. Of course, you know, you don't have to tell Lucas that he did a good job. Lucas already knew in the year 2000 that he did a good job, right? If you kind of read through this, this is kind of the arrogance of having a Nobel Prize in your pocket, right? You can just, you know, just basically call your shot, drop your microphone and say, screw you all, I'm always right, right? But Lucas here says, how did the world economy of today with its vast differences in income levels and growth rates emerge from the world of 2 centuries ago, in which the richest and the poorest societies had incomes differing perhaps by a factor of 2, in which no society ever enjoyed sustained growth in living standards? I have sketched an answer to this question in this note, an answer that implies some very sharp predictions about the future. If you're reading this in the year 2100 or the year 2020, in a retrospective issue of the Journal of Economics Perspectives, I ask you, who else told you what the macroeconomics of your century would look like in advance with such accuracy and economy, right? I mean, you gotta kind of say, screw you, dude. I mean, don't be such an asshole about it. But anyway, yeah, you know, I mean, he was right about a lot of stuff. in the year 2000. But I don't want to give him too much credit. I mean, let's be honest. He's basically taking a version of the Solow model and running it forward, right? So it's not like Lucas came up with this himself, right? But he's too arrogant to say that he stood on the shoulders of giants to come up with this model. But yeah, I mean, this is one of those cases. There's so many cases that it's easy to look at economists' predictions of the future and say, oh, they're so wrong. But here's a prediction of the future that I think has generally been shown to be true. And it's a positive prediction of the future, right? And I do think that when you look at a lot of the growth data, and a lot of what we talked about this week has actually been positive, right? In terms of the dramatic increases in standard of living that we've seen in rich countries like the US, but even the dramatic increases in the standard of living that we've seen in poor countries, right? And the elimination or the dramatic reduction of people living in extreme poverty. And so some of this was predictable, right? Some of this was predictable. Lucas takes all the credit for it, but I don't think we can give him all the credit for it. So that's just kind of an example of, it's not easy, but how you can think about summarizing a paper like this, right? By kind of taking those 4 points and trying to focus on them. And, listen, honestly, those of you who read this probably only read it once. But for the papers that you're going to have to summarize, you're going to have to read these 2, 3, 4 times possibly. At least certain sections you're going to have to read multiple times because, this stuff is just not, it's not simple, right? It's not like reading Harry Potter. You got to dig through it a little bit, right? You got to dig through it. And of course, the thing you can do is you can always ask questions, right? You can always ask questions. You can ask questions of me. You can do Google searches, right? I may not even be able to always answer the questions about some of these papers, but at least I can give you some help. One last thing that I should mention here about this paper is that there definitely are some journals that are better to look for articles than others. This journal or this article is from the Journal of Economic Perspectives. And so I encourage you to write this down. The Journal of Economic Perspectives is actually one of the journals that tries to have a little bit broader audience, including an audience outside of strictly economics. And so I can give you other examples of this, such as the Journal of Economic Literature. These tend to be a little bit more written for the general audience or for undergraduate majors or even for professionals outside of economics. And so, once again, as you collect articles, right, and you think about, well, I've got these 6 or 7 articles that look good, which might be good. I can tell you from experience that if it's an article from the Journal of Economics Perspectives, that's going to be a good one. That's probably going to be a good one because it's probably not going to be as nearly as technical. And because the Journal of Economic Perspectives tend to take a little bit broader questions, right? So instead of focusing on really, really narrow technical questions, they tend to look at bigger, more interesting questions, quite honestly. And so this is a good journal to be looking for when you begin looking for articles this weekend. Okay. All right. So does anybody have any questions about Lucas? So we will have class this afternoon. I hate having class on Friday afternoon, but we'll do it. But it should not be very long. I think we should be able to keep class to 40, 45 minutes. And like I said, I really just want to talk about reviewing some basic principles of econometrics. For some of you, this would be pretty straightforward and maybe a little bit boring. But for others of you, I think this is probably a necessary review. So we'll meet back here at 12:30, okay? Okay, have a good lunch.